Last episode, we talked about a new technology platform. It tracks complex movements and gestures. It uses up to 8 sensors. These sensors measure and analyze movements and give feedback. We call them smart connected sensors.
They get smart by the algorithms that we put on them.
This is Daniel Jung. He's a group manager in the team of Bosch Sensortec in Sweden.
From know-how to wow.
AI hosted Deep Dive.
What we are focusing on here right now is connecting the sensors with Bluetooth, BLE, to be more precise, a low energy version, so that we can run these devices for long periods of time.
We touched on this in the previous episode, but here's more detail. Connecting the smart connected sensors to each other using Bluetooth Low Energy has many advantages. And it is also surprisingly tricky.
BLE is not a good system for time synchronization. Usually do this ping-pong synchronization where you can, when you know the time of flight, you can do a time synchronization, but with BLE you don't know when you're sending something and when you're receiving something. There's something to do with how the Bluetooth stack is set up. But we actually developed a method where you can overcome this problem and you can do time synchronization, very precise, so that you can use all the data that all the nodes collect and they are in relation to each other.
This makes it much easier to make sense of all the data that the leaf nodes send to the central node. Typically, each leaf node processes its data before sending it via Bluetooth to the central node. The central node then fuses these data streams.
That has a lot of advantages. First of all, is you need to send less data over BLE, so you can save battery by doing that. And of course, the central node has less computation to do, so if you can distribute all the computational work on all the leaf nodes, so all the leaf nodes also have a somewhat similar battery drain. If you do everything on the central node, you need to maybe have a larger battery in the central node because it's just more calculations that you do there.
However, this distributed approach is not always the best in each and every scenario.
Sometimes it's just better to look at all the data together. Depends a bit on the use case.
That's why Bosch sells these smart connected sensors as a platform. Customers can tailor them to their needs.
I mean, the smart connected sensors is a platform, and of course we are demonstrating some use cases, but we on purpose wanted to have it as a very versatile system because it's a very fragmented market. You know, it's a lot of different use cases that you can cover with that, and we just want to have it as a platform. So as a customer comes, I want to do that, you can just do it.
So that's the deep dive on the connectivity portion. Now let's move on to the smart portion. That of course means we are talking about AI. Artificial intelligence. Let's start with the data that the AI algorithms receive from the sensor. It can be more complex, but at its core, the sensor is an IMU. This inertial measurement unit consists of an accelerometer and a gyroscope.
So you get three-dimensional information about how the acceleration is happening in XYZ coordinates. And then you need to know that you have a gravity. So if you're not moving, you always have like 1g pointing down in your coordinate system, whichever way it's oriented. And if you start moving, you get on top of that. If you look now at the vector pointing in this three-dimensional space, if you just move a little bit, it will still mostly point downwards where the gravitation is pulling. And if you're doing like strong acceleration, you can see how that vector is going to spin around in space. And then the gyrometer is giving you the rotation, also in 3D space, and that information is what is fed into the algorithm. There is a little bit of processing happening because the gravity is actually quite annoying to have in the data. But, you know, with some clever data massaging, you can make this in a way so that you can use this, and then the algorithm analyzes that data and tries to understand what's happening.
The AI needs to know what it's looking for. Let's make an example. Dance moves recorded by the sensors. This was the case for the demos shown at CES in Las Vegas 2024. Those dance moves had to be recorded using the sensors. Then, that data was used to derive patterns that can be recognized. For applications covering a broad user base, it is important the patterns reflect the variations in how a movement is executed depending on the person doing it.
Let's say you go into the gym and you want to detect like different gym activities. And then we set up a plan. We have a team in Bosch that does data collection. You explain to them what we want. Do also video recording so we can sanity check the data that they collect together with a video. When 10 people do the exercise 10 times, you have outliers and people do it differently. I mean, you want to catch the variation between the different people, of course, but you also want to make sure that the outliers come out. It's a bit like speaking a language, it's a different dialects, so you need to catch the dialects, and that's where the smart algorithm, whatever it is you're using, becomes really smart when it's capable of doing this in a good way.
The gesture recognition itself is based on frequency analysis. Different movements have different identifiers in the frequency spectrum. Daniel says it's pretty complex, but it works well. The frequency data is fed into a machine learning algorithm. Now, most AI systems that get hyped today are neural networks. Yours truly, this voice avatar, is based on a neural network. But the smart connected sensors build upon the more classical approach to AI.
But what a neural network cannot really do is tell you how well you're doing something. I mean, it can tell you what you're doing, and it's like, okay, now it's this one, but it doesn't tell you, oh, you did this that good. And also, if you didn't do it quite that good, then it cannot tell you why you didn't do it that well. If you do the classical machine learning approach, like the one that we are doing with a frequency analysis, we're doing a lot of analysis with the data, and you can tell, okay, you didn't lift your arm high enough, or you didn't do it fast enough, and these things. That's what a neural network approach cannot do. It will not help you with that.
There are a couple more disadvantages to neural networks. They tend to get quite big, quite fast, and they consume more energy than classical machine learning. Both characteristics that are not ideal for an embedded environment. On the other hand, the approach Daniel and his team are taking allows them to make the smart connected sensors very efficient.
We really need to work on every kilobyte and every byte. We try to trim off our application so that the customer has as much space available as possible. And of course, also, we cannot use all the CPU power, and so there needs to be still some room that the customer can run their algorithms on top or whatever they need to do.
Less than 100 kilobytes of code is usually in a smart connected sensor when it leaves the Bosch factory. Each pattern that gets created for gesture recognition adds a tiny amount of data. Less than a kilobyte. That's less than a typical email. Adding a custom pattern is easy, says Daniel.
What we also offer is a nice tool to create the patterns yourself. And of course, with neural networks, you can do that too, but you usually need to collect a lot more data, and then the labeling gets quite laborious to do that. And the algorithm that we developed actually has a nice advantage that you can get away with collecting much less data, and also it does most of the stuff automatically for you. So it tries to simplify the process.
All of that said, Daniel is not against neural networks. They, of course, have advantages too. For instance, when it comes to being able to recognize a large number of different gestures.
I mean, neural networks are very powerful, and they are good for a lot of things. Then, of course, sometimes you just don't know how to solve it with a classical approach, and then the neural network is really great because it somehow figures it out for you. Yeah?
The Bosch engineers are also working on harvesting that power of neural networks where they can best complement the classical algorithms.
What we're also doing now is you can take parts of that analysis and feed that into a neural network, and this can become a very optimized system where you can detect things quite well, and like making this really smart by picking the right algorithm for the right application.
Really smart connected sensors. Thanks to Daniel's fantastic team of engineers.
From know-how to wow.
AI hosted deep dive.
Next month, our topic will be systems that can detect tiny movements as well. They use them to determine whether a driver is sleepy or drowsy. But beyond safety, these systems come with amazing convenience functionalities as well. Of course, powered by AI.